Hi, welcome back to another video from Insectix Android Application Penetration Testing course. In the previous video we have seen application sandboxing under Android security model. Now in this video we're going to see secure interprocess communication. So basically this slide explains what happens if you don't properly implement secure interprocess communication. By default Android provides these options for us to implement interprocess communication in our applications, right? So sometimes when these interprocess communication methodologies are not properly implemented, then your applications can be exploited. So we'll see some of the demonstrations in the later videos where what happens if your interprocess communication is not properly implemented in your applications, right? So in this video let's understand what they actually mean. So basically interprocess communication is provided in these means binders, services, intents and content providers. So binders are basically a lightweight capability based remote procedure call mechanism which is designed for high performance when performing in process as well as cross process calls, and this is implemented using a custom Linux driver. Now intent is a simple message object that represent an intention to do something. For example, looks like I have a mistake in this presentation. That's fine. So services basically are the background processes. For example, you have a screen on your device. If you want to let's say you have a screen on the device which is doing some kind of processing. Now if you want to do the same processing without having a screen, you can actually do that using services. Your services can also be used to trigger something. If you want to start an activity right from your service, yes, you can do that. If you want to do some kind of processing in the background, yes, you can do that using services. So now services can be used to interact with other components in your application as well. And the next one is intents. Intents basically are the messages that represent an intention to do something. For example, you have an application A, and application A has two screens, screen 1 and screen 2. Now if you want to start screen 2 from screen 1, you can use something known as intent. So basically intent is a message which says, hey, I want to launch you, right? So that's the intention. So the intention here is to launch the second activity from the first activity. So in this case, first activity will start second activity using intent. Now let's see a quick demonstration of how we can actually use intents right from ADB shell. Right, so in this case I'm not going to use an application, rather I'm going to run this command using AM, which stands for Activity Manager, to launch an intent which is http www.google.com. I want to see this. Now in this case it's a system event. Now when I type this command in my ADB shell, a broadcast will be sent and your system knows what to launch. So the appropriate intent which will be launched. In this case, browser will actually be opened and this google.com website will be opened inside your browser. So let's quickly do that. So this is going to be a command. Let's quickly copy this, and this is the previous one. Oops, I have pressed screenshot. Let's quickly alright, so let's we already have a shell on the device. Now if you see this, let's click home button. Now if you see this, browser is not launched so far. Now let's paste it here. Now if you go back to your browser, the emulator, you should see the browser is getting launched and it should open Google. Looks like my browser is crashed here, but if you try this in your emulator, you should get it. let me launch an Intel emulator, because seems it is crashed. Let me close this. ADB shell, device offline. So let's wait for this device to start. It is Intel based. It will be faster when compared to the previous one, which is ARM based. But you don't need to create an Intel one. You can actually try that right in your ARM based machine. In my case, I don't know why it is not working, but it should work. So let's wait for this device to launch and try this here. If it still doesn't work here, maybe you can try it on your own. Since I'm launching it for the first time, even Intel machine is taking a lot of time, but once after launching it will be faster when compared to ARM machines. So let me launch it. Probably I'll pause the video till it launches here, and I'll just quickly come back once it gets launched. Well, the emulator has been launched. Let's quickly open it up, and now if you type the command ADB shell, you should be able to get it over there. Now type this and go back to your emulator. You should be able to see your browser gets launched now, and as you can see, it is now launching google.com. Right, so this is basically an intent. We are sending an intent to your system saying, hey, I want to open www.google.com. Right, now it got opened. So this is basically what is known as an implicit intent. Because we are launching a system event, we are not explicitly mentioning, hey, this is what is supposed to open my google.com. We are not mentioning the target, but automatically the browser is opening your google.com, right? So this is what is known as implicit intent. In some of our later videos, we'll also see something known as explicit intents, right? So this is your intent. So basically it's a simple message object that represents an intention to do something. In our case, our intention is to open google.com in a browser. Now the next one is content providers. Content provider is something like a data store house that provides access to data on the device. It's a pipe. Let's say you have SMS application. SMS application will have a database to store all your SMS. That is what we have seen in the previous video, if you remember. We have taken out the database and we have seen the contents of your database, right? Select which is mms_sms.db. Now content provider is a pipe between your application and the database. Now the data that is there inside your database can actually be extracted by your application using this pipe. So it's a bridge. It's something like a bridge. Now if one application can access the content provider of other applications, that's dangerous, and that is the reason why your SMS application needs read SMS permission to be able to access its content provider, right? So everyone cannot access the SMS of other the inbuilt application. So if I want to access the SMS of the application, if I want to access the SMS from SMS application, I should my application should register with a permission called read SMS. So only if I register with read SMS permission, I will be able to access the content from this content provider. Right, we'll see this practically in later videos, but as of now, since we are understanding the Android security model, I think this is more than enough. Right, so that's all I have in mind for this video. I think in the next video we'll see Android permission model, so we'll discuss those things in the next video. So thanks for watching the video. Thanks a lot.